Hey, welcome everyone to the session. This is TDR 204. My name is Himanshu Verma. I'm a worldwide security specialist. I lead the go-to-market strategy team within AWS for our native AWS security services. We cover the full breadth of our security services, from data protection to edge and network protection, to threat detection and monitoring, and privacy and compliance. And I'm joined today with one of our uh, local AWS security expert who actually helps manage the security within AWS, Michael Banks. So he'll be joining me later. The session today is to walk you through real world lessons on how to operationalize security findings. So there'll be examples that Michael will share on how AWS actually operationalizes security findings. And I'll set the stage on some of the key use cases that we hear from customers and how AWS ourselves acts on those use cases. So the things we'll cover, I'll provide you an overview of the layered security approach that customers can orchestrate using native AWS security services, as well as our governance and management tools. The top 10 security use cases, both tied to personas who interact with security in organizations. Some of the key service examples and workflows. I'll also have some reference resources that you can leverage. And then finally, I'll give it over to Michael to explain how AWS actually leverages these use cases and operationalizes them. So first and foremost, let me set the stage with the breadth and the depth of AWS security services. We have quite a few services that customers can actually leverage as building blocks to orchestrate a full layered security approach. Typically, we will address them in security domains, but the best way to align to them is by looking at use cases or aligning them to a cybersecurity framework. In this case, I've taken the liberty to align them to the NIST cybersecurity framework that highlights some of the key use cases. First and foremost, customers need the ability to identify what all workloads do they have in the cloud. Also need to identify and have an inventory of what all controls are there in their environment. So as your AWS environment's growing and you're adding more accounts and those accounts are adding more workloads, you need services such as AWS Security Hub and or AWS Config that can help evaluate that inventory and evaluate those controls and provide visibility and help identify those resources. Once customers have identified, then you can actually put on protection or add protection using native AWS protection services. These services are mainly aligned towards protecting data at rest, in motion, or in use. So using native AWS cryptographic services such as AWS KMS and or scalable PKI and secrets manager services, you can leverage these services to protect data and applications as they interact with each other. Additionally, our infrastructure protection services, such as Shield, Network Firewall, Application Firewall, help protect communication to and from AWS and data coming to and from AWS as well. After that, customers need the ability to proactively detect any suspicious, any malicious, or any abnormal activity, vulnerabilities, and or need to detect any non-adherence to best practices or compliance. So this is where some of our native detection services come into play that help customers detect where their gaps are and where they need to act or respond. All of these services will generate what we call findings. These findings are available either in the service or can be automated through EventBridge to leverage step functions or Lambda, which are native to AWS, and then have a response action. So this helps customers to automate a response to those findings or events. More mature customers who have a security operations center or security analysts would further want to investigate the root cause analysis of the event so that they can address and respond to that in a more precise fashion. This can be done either using the raw logs that are available or native services such as Amazon Detective that can help build a correlational behavioral graph that can help customers dive deeper into the root cause analysis of issues. And then when it comes to response, most of the times customers want to recover from either a situation or an event that has occurred, and then you can use automation tools such as CloudFormation and or our backup and recovery tools and our resiliency tools such as Cloud Endure. So this is a mental model for customers to layer security services based on use cases using a combination of both our native AWS security services as well as our management and governance tools. Now, if I put the lens further on threat detection and monitoring, this is sort of like how the threat detection and monitoring domain looks like. Most of our native services here are actually integrated at the AWS account level, and they do not require any additional operationalization and or any additional logging to be enabled. GuardDuty, which is our primary threat detection service, once enabled at the AWS account level, automatically starts collecting telemetry and monitoring events in CloudTrail, in flow logs, data in S3, and more lately, EKS audit logs for Kubernetes protection, and then is able to send that to a managed threat intelligence engine as well as a machine learning model to then highlight either suspicious or malicious activity. Amazon Macie, which can also be enabled at the account level, directly integrates with Amazon S3 for identifying sensitive data at scale, as well as monitoring any control plane policy changes on your data in S3. Amazon Inspector can help with vulnerability management in instances as well as container workloads. And once enabled at the account level, it's again continuous and it automatically detects any event changes in these resources and is able to report vulnerabilities in operating systems or language packs. And more importantly, is also able to highlight network reachability of these resources so that you can go and take response actions and remediate that. The findings from all these services route to AWS Security Hub, which is our centralized monitoring and cloud security posture assessment service. Security Hub provides customers the ability to aggregate these findings, normalize these findings into a single format, and then allows customers to automate response and remediation easily from one place. More importantly, Security Hub is also evaluating controls based on best practice standards using either AWS's internal standards and or external industry standards, and then highlighting whether or not customers' infrastructure or their AWS workloads are secure or not, and what are the gaps where they need to take actions and prioritize their actions. And then finally, Amazon Detective that collects all the CloudTrail information, the flow log information, as well as Kubernetes logs, which was just announced yesterday, and then creates a behavioral graph on top of GuardDuty findings so that customers can differentiate between a benign event and or a threat activity and go as far back as 12 months to actually go in and investigate those issues and take more precise actions. Next, let's dive into the top 10 security use cases and how us as in AWS are acting on those as well. I'll give you some best practices and examples, but before I jump into the use cases, I want to address who are the key personas that we see at the customers handling these security services or interacting with these services. First and foremost, it's the security engineer and or the security team, the centralized security team, which oftentimes is also part of the Center of Excellence and or the Cloud Security Excellence program. The security teams or the security engineers are the ones who are the frontline incident responders to all security incidents. They are constantly monitoring events and findings from these services and then helping the development teams take actions, corrective actions, wherever necessarily, if it's early in the application development stage or in a pipeline, or they're then creating tickets and or items for other teams to act on. The second key persona is the DevOps or the developers who are building these applications. The security teams often interact with the development teams or the development teams also have a responsibility to ensure when they're building applications and they're building pipelines or pushing code through their pipelines, they're responsible for making sure that the security of that application is also maintained. This is where we also see a convergence of responsibilities between the DevOps and then the security ops. And hence there's a terminology that's being used in the industry of moving security left and or DevSecOps as a converged use case. So let's dive into some of these use cases now that we've covered the personas. First and foremost is the ability to maintain an accurate inventory of accounts, resources, and applications. As I mentioned, as your AWS workloads grow, you need the ability to baseline what does good security look like, and then have the ability to evaluate controls as well as ability to evaluate inventory and have visibility into that inventory. Using some of our services such as AWS Control Tower and automating with AWS CloudFormation stack sets, customers can easily provision accounts and workloads in those accounts, which can scale based upon that security baseline. You can decide which policies are enabled, who has access to what, and then once those are defined, you can then easily scale these and automate these for future account provisioning without having to consistently worry about whether or not those policies are still being met or not. The second primary use case is to verify the configuration of those assets by identifying and enabling preventative and detective controls. As the policies are being defined in those accounts and new accounts are provisioned, one of the other measures that customers take is to enable the appropriate preventative and or detective controls in those accounts. This includes enabling services like Guard Duty, enabling some raw logs so that you have visibility, and or enabling services like Security Hub so that you can continue to evaluate controls and continue to have visibility into findings, either suspicious or malicious, for your new accounts that are provisioned. These services also integrate with AWS organizations, which is also a best practice to leverage when it comes to multi-account management and or for the security or DevSecOps personas to have one centralized place to aggregate the findings or visualize these findings. Again, using Control Tower and or using the create manage account function, this can be easily triggered where you have these services enabled. And we've also given the ability to customers within AWS organizations to have auto-enable these services for the multi-member accounts as well. The third key use case that I want to highlight is the ability to automatically enable security features and monitor their coverage. So I highlighted preventative and detective controls. However, customers need other security features such as network security and or vulnerability management. And this is where Security Hub helps provide that visibility to customers where they can view in one place what all native AWS security services are enabled and or are integrated with Security Hub. The 5 services that are highlighted on the left are Guard Duty, Macie, Firewall Manager, AWS Config, Inspector, as well as IAM Access Analyzer. These native AWS security services, their status, as well as the findings from these services are automatically sent to Security Hub. Additionally, Security Hub also integrates with third-party tools that can help aggregate the findings from not only the native AWS services, but those third-party tools as well in one single place so that your security teams have quote-unquote the single pane of glass to go and view or filter these findings. Security Hub also allows for then the ability to create insights, which are groups of these findings based on your customized needs or using built-in insights that are available in the service. This provides better visibility for security issues and also easier to stay in compliance because Security Hub is also evaluating controls for governance as well as compliance purposes. The next use case is the ability to detect, normalize, and aggregate security findings and logs. Typically, security teams have a lot of cost and operational overhead when dealing with multiple vendor findings or multiple vendor events, and they need the ability to normalize them into a single format. Sending these findings to Security Hub actually normalizes these findings into Amazon Security Finding format. So customers leverage Security Hub as the key aggregation point, not only to evaluate controls and to ensure that they're meeting compliance or governance, but they also route these findings to Security Hub so that once these findings are sent out of Security Hub to either built-in partner integrated tools or centralized security incident event monitoring tools, SIEM or a SOAR, for example, they are all normalized so that their operations or security operations team have one single format to actually go in and write their automated response actions on. This takes away the operational overhead and cost associated with reacting and or responding to these events. The next use case is the ability to enrich, correlate, and prioritize security findings. The security teams not only need the ability to aggregate these findings, but they also want contextual inputs and they want insights that can be added or enriched on top of these findings. I'll give you an example here, and this is a solution that is actually posted on one of our blog posts that shows how findings from Security Hub can be routed automatically to EventBridge through multiple member accounts or through a centralized aggregated account, and then using step functions and Lambda, customers can actually enrich that information by routing all the findings to a DynamoDB table and then adding information on top of that. Let's take an example. When GuardDuty generates findings, we actually, part of the contextual data of that finding also suggests to customers what are the remediation and response actions. This information is usually in our documentation. Also, Security Hub is aggregating information from multiple security services, such as Inspector for vulnerability management. So any instance that's exhibiting a vulnerability, such as Log4j, that'll be reported into Security Hub. Or an instance that's exhibiting an exploit or has been seeing port 22 RDP brute force, that's a finding that GuardDuty will also generate and send it to Security Hub. Now, the ability to enrich this information is something that customers can orchestrate and automate using this solution by sending those findings into a DynamoDB table, looking for the instance ID, and then adding that context and correlation onto that finding data, and then ingesting that data with batch update findings API of Security Hub. This allows to add that information into the metadata so that then Security Hub can route that information into the SIEM tool or the SOAR tool, and then that gives a lot of contextual information to the security team to go and take immediate response. That also helps reduce the mean time to response as a result of that. The next use case is to investigate security findings. This is where customers need the ability, or the security engineers or the threat analysts need the ability to dive deeper into the root cause analysis and look at trends of either abrupt API calls, failed as well as successful, and or look at trends where they want to differentiate between an actual event and a true threat. Amazon Detective is our service that can today be launched either through GuardDuty findings for investigation, or if you're aggregating those findings in Security Hub, you can also launch Amazon Detective for investigation from Security Hub. And then additionally, you can launch Detective from some of our partner tools as well. Detective actually creates what is called a behavioral graph database. The behavioral graph database looks like linked entities or linked nodes of various different entities involved in a finding. These are common things such as a user or a role or what session was asserted by that role. and or what IP address that request came from, what location that request came from, and then what resource was impacted, such as an instance or a Kubernetes pod, etc. You can start your journey at any one of these nodes, and then using Detective's interface, you can go ahead and start navigating to any one of these details so that you can pinpoint the actual root cause and investigate the security event further. Typically, customers can start the journey from a finding, which is a GuardDuty finding, or customers can log in straight to the Detective console and then pick up or search for one of the entities represented here and then start their journey from there. This not only provides you visibility at that particular snapshot of time, but Detective is retaining 12 months worth of data. So it's helping customers make it easier to operationalize the raw logs, and instead is trying to build all that correlation for the security team. So using that 12-month period, the security teams can actually adjust the scope time and go back as far as 12 months in time to view where do they see variances in API calls, and then choose any specific variance to see what API calls were made, what actions were taken as a result of those. After investigation, the next use case is the ability to manage exceptions and SLAs or service level agreements for acknowledging and resolving findings. This is typically also a big responsibility for the security engineers to ensure that the security SLAs and or the incident response SLAs are met in time. This is an example of a solution that Security Hub provides security engineers the ability to have bidirectional integration with ticketing and or SLA management tools such as Jira and or ServiceNow. Using the bidirectional integration, this not only allows the security teams to update the status in those respective tools which they are using and then see the same status update in the Security Hub workflow, but also allows them to communicate those status with the development teams as well. In this example, you can see where a finding that is generated through Security Hub is routed through CloudWatch event into Jira, which is related to Secrets Manager. So if the secret has not been rotated after X number of days based on a security standard, that's a control that'll show a high severity finding in Security Hub, which can then be leveraged to open an automatic ticket in Jira, and then can automatically be used to notify the development team to go ahead and address that. This again creates that bidirectional channel of updating the status, because once the developers address that, he can go and update the status of that finding in Jira, which will automatically be also reflected in Security Hub. The next use case is to automatically export, respond to, and remediate findings. This is where customers need the ability to add more insights or have that finding data that they have so that they can respond to or remediate to findings easily. As part of our remediation and automated remediation initiative, Security Hub does have a solution that is available in the form of what we call either runbooks or playbooks. This allows for detection, where Security Hub provides a comprehensive view of security alerts, ingestion, where the findings from Security Hub are automatically sent to EventBridge, and then you can write custom CloudWatch rules in EventBridge to take automated actions and response, which are in turn done by calling step functions or lambdas, which will help remediate that situation. And then finally, logging that to make sure that you have an audit available of what action was taken. These are a collection of events that can automatically be imported into Security Hub in the form of runbooks, so that you can have use case-based runbooks and or playbooks that can easily be executed for a collection of the security events from within Security Hub. The next use case is the ability to identify, investigate, and recover from security incidents. This is where customers need the ability to not only investigate, not only go ahead and identify, but also recover from security incidents. Here is an example that I wanted to share with you that is also available as a solution blog post and a CloudFormation stack. You will notice here that Security Hub is where findings are getting aggregated, and GuardDuty, as part of its threat detection, is able to highlight a known malicious IP address which is being observed in a threat. That finding, which includes that IP address, is then routed to Security Hub, through which it then goes through a CloudWatch event rule to invoke a step function, which then tries to understand whether or not that IP address is already in the block list of the network firewall or not. So you can see here that an IP address that is detected in a threat vector and or malicious activity needs to be blocked as a recovery or a remediation operation, and that can be automated using Security Hub, using CloudWatch event integration, calling the step function, creating a database of those IP addresses, evaluating that, and then adding that automatically to the block rule of the AWS network firewall. A similar use case can also be applied for DNS use cases as well. GuardDuty also reports on DNS sources, which can then be leveraged with the AWS Route 53 DNS firewall and then added to the block list there as well. And finally, the last use case that I want to highlight is the ability to track and report on security metrics. As part of the security team, they also need the ability to provide insights, either in the form of custom dashboards or business intelligence tools to their teams, so that they can share that data and use that data or harness that data for future purposes as well. This is again where Security Hub acts as the centralized aggregation point for collecting all the finding information, and then customers can route that information through EventBridge into Kinesis Data Firehouse to a storage location such as an Amazon S3 bucket, and then using Amazon Athena and custom query sets, they can create custom QuickSight dashboards for visualization and or business intelligence. This example here, or the solution, highlights the same where using AWS Glue Crawler, we can pull the schema of the data from Amazon S3 and query the data from Amazon Athena to then present that into custom dashboards in QuickSights. The same solution can also be leveraged for other BI tools, for example, Kibana, etc., to represent those incidents. So now that I've highlighted these 10 use cases, I want to hand it over to Michael, who can highlight how AWS security team operationalizes these findings.
Thank you. So my name is Michael Banks. I am the Security Engineering Manager within our Security Operations Center in AWS, our SOC. And I lead a team that really takes these type of findings, operationalizes them, scales them, and responds to them. Today, we wanted to go through some finding types and give you an approach and show you how we operationalize some of these findings. Now, the concept we're going to explain today is going to be focused on GuardDuty, but the same approach can be taken for any type of security finding that the organization deals with. So the 4 different considerations and areas I'm going to touch on today is really onboarding and prioritizing some of the findings that organizations have to deal with. We'll touch on a bit on the enrichment perspective and focus on the response elements around some of the actions that the actual responders and engineers take for operationalizing some of these findings. Lastly, we'll touch on the feedback loop that we have and some of the different perspectives and considerations we take in giving feedback, not only to service teams, but also to the systems we utilize as well to respond to these type of findings. So the first area I mentioned I'll touch on is really onboarding and prioritizing some of the findings. Again, we're focusing on GuardDuty for this example. So I wanted to give a reminder around some of the different considerations you'd look at when you're thinking about a guard duty finding. So you have like your threat purpose, which in this case is a backdoor finding type. Then you have the resources that's affected, the resource type that's affected. So if it's EC2, or if we're talking about Lambda or other services or S3. Next, you'll see the family name, the threat family name, and then you'll see the detection mechanism that is utilized to detect the finding. So in this case, we're talking about denial of service attack, and the detection mechanism is TCP in this case. So if it was UDP, it would come in UDP in this example. Lastly, in terms of prioritizing from guard duty that exists today, is you have the actual severity. So you have a low finding, which is given as an integer value, really more of a double integer type, medium, and then high. So those are the three severities that guard duty findings come with today. So some of the approaches we looked at when we were talking about onboarding and prioritizing is, as I mentioned, really focusing on the threat purpose and really that family name around the finding. The resource is important when you're talking about the service that gives you the threat and that landscape of what you're protecting. So if we're dealing with EC2 or Lambda, we have to keep in context, what resource is the organization using? So if there's a customer or that doesn't use EC2 perspective, maybe some of the finding types would not be something you would focus on, but you have to look at the finding types and detections that exist today in guard duty and match them up with the resources and detections that are in the service today. So what we did is, that's more around the scope, that left and right limit, but what about the scale? What about the input? If we take EC2 as an example, once you turn on guard duty and you have that snapshot that guard duty runs for 30 days, what's the number of findings you're getting with? How many findings are you dealing with? What type of findings are you receiving? Once you take those, look for the past 30 days, then you can prioritize what type of findings you all have to deal with, or what type of findings the organization has to deal with. And really that gives you a perspective of what you can focus on. That way you're not engaging in planning for finding types you're not actually seeing in your environment. So if you look for the past 30 days, they'll give you a snapshot. Now you can look further back if you have that data. And you should do this on an annual or some cadence base to actually look through findings to say, I started in this quarter with these type of finding types, but maybe Q4, a different quarter, you might see something completely different. So keeping these concepts in place is definitely important. The last thing I want to touch on in terms of onboarding and prioritizing is the severities. So these severities may not match up with how the organization utilizes severities. So you have your guard duty severities, but if organizations are using a ticket-based system severities that may be 1 through 5, they may not match up with how the guard duty findings exist. So you really have to do that mapping between what is a low for the guard duty platform versus what's the severity for the organization. So as I mentioned with matching that up, once you have gone through this onboarding phase, you've looked at your data for the last 30, 60, 90 days, and you've done this mapping. Once you have the guard duty findings and types you want to focus on, next you have to dig deeper into what type of findings these are and how are they affected. So guard duty utilizes data sources for these finding types. So currently there's CloudTrail that manages event logs. There's data events that's used for S3. There's EKS, audit logs, and VPC flow logs. There's a number of different data sources that generate guard duty findings. So one of the things, once you understand the data sources, is how do you utilize these data sources, understand the detection mechanisms, and make them actionable? So really the question you have to ask yourself is, what information is needed that the data sources don't give you to make them actionable? Some of the considerations that we looked at is, who's the right owner? Sometimes there may be an account that exists, but the account may belong to the entire team. It may belong to the director or the IT director or the CISO or the CIO. They may own the account, but there are teams that respond to issues and own certain infrastructure within that account. So you may have to do that mapping within something like an Active Directory, mapping that information around who owns this account, what sub-team owns this account, what cost center owns this account, and then route the information and finding over to that team. And again, we mentioned on the last slide about severity. This is the opportunity to where you can enrich that finding and match in, this is the actual individual that corresponds with this finding type. This is the actual severity that we've determined that matches up with the severity or may not match up with the severity from guard duty. But this is our opportunity to take that information and actually put it within the finding itself. This can be done in Security Hub, but it can also be done in things like Lambda to actually enrich the finding type itself. And then lastly, one of the considerations you have to do is what systems actually holds the information that you need to enrich the finding type with. So like I mentioned, Active Directory. But if there's another asset management system that might actually hold this information, what system holds this and how do you get it to that finding type, or how do you get it to the platform or ticketing system that actually does this? So really, it's a mind of getting the finding information, getting the enrichment information, and marrying that together in some form or fashion. Now, the example I'll give is, here's a sample guard duty finding, and some of the information you would see from a finding, but may not exactly incorporate some of the information you might actually need, like I mentioned on the last slide. So a standard finding type, you'll get the account number, but where's the actual information around the individual owner or team that actually owns the finding? Some of the other enrichment opportunities you have is, this is the region or this is the AMI that's involved. What information is classified within these accounts? What is this instance actually doing? What role does it play in the organization? There's tons of information you can do. And then lastly, I want to point out is credentials. If this account and guard duty finding is talking about a credential, what credential was used? Now, sometimes the credential ARN is included in the finding, but maybe you want to pull in that policy. Maybe you want to actually make it easily and readily available for engineers and responders to actually take action. So I'll touch on using this finding and this information on the next slide for other considerations around some of the finding types. So like I mentioned about roles and access keys, you might actually want to pull the individual role, the policies attached to it, the trust relationship with that IAM role, and again, matching it up with the organization severity to the guard duty severity that may be in line with what you determine a finding is, and it may not be. As I mentioned before about accounts, you can have different types of accounts, but all accounts are not equal. Is this a production account that holds the actual organization's website? Is this a non-production account that someone is just testing on? Adding this information to the finding is very important to the organization and to the responders to make different decisions in responding. Some of the team-specific routing I mentioned, if there is an IT account for all IT department, maybe there are sub-teams on the IT department. You can actually do team-specific routing and enriching around providing that information to the responder that's more in depth than putting something in the description or details field about an account. And really, putting the individual owners in there, that way you make routing quicker and easier. Lastly, of route enrichment, if you're familiar with your organization's spin, maybe it's something like a crypto mining finding, to where you see a big spike in spin. Spin information may be a good indicator around something that's weird that's happening in the account. If the responders receive this information and see spin, maybe that's another vector that might be important for an account and a finding. And not just spin, but spin over time. So for the last 40 days, if an account only spent $10 of use in an account, and then month to date, they've done 1,000, that's not an indicator of compromise, but that may be something that's interesting that can correspond with a crypto finding that might be able to be married to it. So maybe you pull that and enrich findings based off of spin as well. And that's where you have to match that mechanism of detection to where that might be interesting. Since we've talked about enrichment, I'll actually move on to one of the areas that we focus on a lot in the SOC is response. Having runbooks attached to the finding itself has been found valuable for responders to respond to. Sometimes you can make action items out of findings. So if you're using a ticketing system and you have the actual runbook or policy or things the responder has to do, maybe it's a checklist, If you have these things in the ticket itself, it makes responding quicker and easier. A big thing we've done many campaigns internally, and one of the immensely important and time-saving thing we've done is when engaging teams, explaining the finding to them. Everyone is not a security professional. Explaining what the issue is, what's the impact, what's the value of the finding, and what is it we're wanting them to do, in some cases can speed up response time when it's not in your hands to actually do. Sometimes you can do alerts to other response team based off the finding and based off the relationship. So sometimes organizations have multiple security teams. If there's a finding that hits one of the security accounts, maybe you also send a ticket to the team, but maybe you also send a ticket to the other security team that actually works with that team. Maybe they have security engineers attached to the team that actually runs that. You can actually put in alerts based off the alert mechanism that team does. So once you go grab that team information, you might pull in, how is this team engaged? Do they only engage via email? Do you have to page someone to it? You can actually take this information and this feedback, which you'll see in a later slide, and embed that into your response plan. And then lastly, I'll mention here is automation. Automation is important. It's how we scale. If you can have a finding, map out the severity, have who it's responsible for, and route it to them, maybe you already were able to take action and remediate the finding itself. And now you're sending a notification. We've done this for you. FYI, we've solved the problems, but you may want to do X in the future. That way we don't run into this. Having that response and automation there, in addition to the ticketing and alerting, is important, and that's a way you can scale. So runbooks, ticketing, alerting, and automation, once you have that enrichment data, you can take quicker and more efficient response in some of the feedbacks. And lastly, the feedback loop. This is a big one as well in learnings that we've done in many campaigns. Feedback loops is how we discover that, explaining the findings, the value and impact to teams. We were able to get that from working with teams themselves. We don't want to be the team yelling at service teams, telling them you can't do X or Y or Z, getting the information on what they're trying to do, why they did it, where did they get the information from, and really solving those problems will solve problems down the road for the responders, but for the organization itself. If there's an instruction manual to do a bad thing inside the organization that they might not have thought was a bad thing, getting the information around, resolving out that finding and moving on to the next finding, but actually going back, updating that instruction, updating that manual of the wrong thing to do, or maybe not the best thing to do, will solve maybe hundreds of tickets in the future. So really creating that feedback loop between the security team, between automation and ticketing for organizations, we found is immensely impossible, but it's also possible by ways of grouping findings, grouping open findings, and future development efforts. If there's a process we see a team doing and we want to improve that process, maybe actually sending that information to the application security team to actually say, we've seen this bad instance or we've seen this wrong behavior a lot of time. Maybe we want to add this into our checklist before we launch a new service. That way we don't see it again. Making response married up with the development cycle before it launches increases response in the future as well. So even though we're responding, having a feedback loop that's more earlier in the process before launch solves problems. And lastly, even though we're automating a lot of things, everything cannot be automated. We strive to do that, but judgment is needed. And sometimes it might take judgment to engage a service team or another security team or a team that doesn't know anything about security. Having that engagement, that relationship is important to make that feedback loop. Now, sometimes you engage teams, you have this feedback loop, you have this dialogue, and sometimes it's just there. Someone's accepted a risk. It must be this way. This is our business. We must do this thing. So exemptions are needed. This is also part of that feedback loop Sometimes customers may be doing something, testing things out like a canary. Sometimes teams may be doing this to test controls or mechanisms that are in place. So putting in exemptions is important as well. That way you train your system to know what known good looks like, but also known bad as well. Thinking about it, not just exempting an entire account, but exempting account to get that information, but even at the finding level of this account, they're doing testing around this resource on this design, and you can actually exempt based on that information. So having that feedback loop in learnings, but also exempting is definitely important in such a feedback loop for the organization to be able to scale, automate, and respond to findings. So lastly, I want to touch on some key takeaways for the talk that we saw today. Really, some of the key takeaways, if you caught nothing from this talk, is really identify the personas, identify the people involved. Is it the service teams? Is it your security team? Is it the leaders of the organization? Is it the decision makers? Is it the customers themselves? Really identify who's involved in the finding, in the use cases, in the data stores, or even in the tooling. Identify who those key stakeholders are. Transition security requirements into stories, and particular user stories. Start with that use case. What is it you're trying to do and what problem are you trying to solve? And then inject security into that use case. It is a business and we're trying to get to, solving customer problems, but transition security requirements into those stories as well. Sometimes in solving a problem, you'll see what security is needed to solve that problem. And really, as you saw at the beginning of the presentation, apply a layered security approach. Don't just solve problems from one perspective, from one entry point. There's an entire perimeter around the organization and around the product or tooling you're putting out there. So really apply a layered security approach to it as well. So those are the key takeaways. I want to thank everyone for coming to the talk, learning about some of the security use cases and how AWS Security operationalizes security findings. Last thing I want to put out is please complete the session survey and hope everyone has a great rest of their Reinforce.